To calculate the solubility of lead iodide in water, first let's write the equation for the equilibrium. So PbI2 is slightly soluble and will dissolve into Pb2 plus ions and iodide ions. And the KSP is equal to concentration of lead ions times the concentration of iodide ions squared. If X is the molar solubility of lead iodide, or the number of moles of lead iodide that will dissolve in 1 liter of water, we will produce X moles of lead ions per liter and 2X moles of iodide ions per liter. Plugging in our ion concentrations into the KSP gives us 8.7 times 10 to the minus 9 given equals X times 2X squared. We get 4X cubed. And to solve for X, we will divide both sides by 4 and raise everything to the 1/3 power, which gives us X equals 1.3 times 10 to the minus 3 molar, and that's our molar solubility in water. To find the molar solubility of lead iodide in potassium iodide, we start with the same equilibrium equation for the dissolution of lead iodide into lead ions and iodide ions, and the same KSP expression but we also must take into consideration the potassium iodide that's present. Potassium iodide is completely soluble and will dissolve 100% to yield K plus ions and iodide ions. We are dissolving our lead iodide in 0.236 molar potassium iodide, which will dissociate 100% and produce 0.236 molar iodide ions. Since we have a common ion, we have to include the iodide produced from the potassium iodide into our expression for KSP. Again, if X is the molar solubility of lead iodide, we will produce X moles of lead ions per liter and 2X moles of iodide ions per liter. Plugging in our concentrations into the KSP equation, 8.7 times 10 to the minus 9 equals X for the lead ion concentration, but this time we have two contributions for the iodide concentration, 0.236 plus 2X, and that would be squared. We can assume that 2X is going to be much less than 0.236. And we can neglect the 2X term in the iodide concentration of the KSP. And this will give us 8.7 times 10 to the minus 9 equals X times 0.236 squared. Solving for X, we get 1.6 times 10 to the minus 7 molar, which is the solubility of lead iodide in potassium iodide. Notice that the solubility in water is larger than in potassium iodide.